So we have an interesting problem here. The integral of x times arctan of x with respect to x. So there we go. Look at this problem. We have a product of a polynomial and an inverse trigonometric function. So how do we solve this? We have to use the technique of integrating by parts. Let's go ahead and do that. So I'll write down the formula for integrating by parts. So if I have the integral of u times dv dx with respect to x, this is going to be the same as uv minus the integral of v du dx dx. Now, of course, we have to be very careful which function we choose as u and which function we choose as dv dx. In this case, it is a little bit easier to integrate x. So I will let u to be tan arc of x, and then I will let dv dx to be equal to x. So I'll go ahead and let u, let u equal to arctan of x. So how do I find du dx here? So du dx, okay, du over dx is 1 over 1 plus x squared. I hope you can do this derivative. If you can't do this derivative, I'll leave a link in the description to another video where I actually show you how to find derivatives of inverse trigonometric functions. Okay, so here we have du dx. We'll come back to this. Let's go ahead and also find x. So from here we see that u is actually arctan of x, so that means dv dx is going to be that, the x. So we'll go ahead and do that. So dv dx is x. So this is a simple differential equation that we can find the value of v from, that's going to be dx. I put integrals on both sides, so v is going to be x squared divided by 2. Okay, so let's put all this into the formula, this and this, for integrating by parts. So we'll have the integral, just have to make this smaller. Okay, so the integral of x arctan, x arctan of x dx. So this is going to be u times v. In this case, we have u as arctan of x and v is x squared over 2. So minus the integral of v du dx. So what's our value of v? That's x squared over 2. Our value for du dx is 1 divided by 1 plus x squared. Okay, so just draw a line here, separate 2. Let's proceed. So now we have, I'll just write only the right hand side. So that's equal to x squared divided by 2 arctan of x minus, I'll pull out a half as a constant, the integral, there's a dx here, got to show that's important. So I have half as a constant, then we have x squared divided by 1 plus, okay, this is going to be x squared here, 1 plus x squared dx. Okay, so we have to evaluate this integral also, and as you notice in this integral we have x squared divided by 1 plus x squared. This is something called an improper fraction because the power of the numerator and the highest power of the denominator are actually equal. So let's go ahead and first resolve this by using synthetic division. Okay, so we'll divide this first. we are working on only this. So we have x squared. We divide that by 1 plus x squared. So x squared divided by x squared, that's actually a 1. Then 1 times this, so that's going to be x squared plus 1. If I subtract this, I get negative 1. So all this x squared divided by 1 plus x squared is actually 1, this 1 here, minus 1 divided by 1 plus x squared. Okay, so now this is easier to integrate than this. So I will write the equation again. Just pick another color here. So I'll now move down from here. So we have x squared divided by 2 arctan of x minus a half the integral of 1 minus 1 over 1 plus x squared with respect to x. Okay, hanging, we're almost there. So finally we have x squared over 2 arctan of x minus a half. So let's see what happens if we do this integral here. The integral of 1 with respect to x, that's going to be x. And then the integral of 1 over 1 plus x squared, this is a standard integral. It's arctan of x. Okay. You can see that from here, by the way. When I get the derivative of arctan of x, it's 1 over 1 plus x squared. So if I integrate this, I've got to get back arctan of x. Still, if you're not sure how this comes about, I'll leave a link in the description to another video where I talk about tan substitution in integration. Okay, of course this is an indefinite integral from the question, so I have to add an arbitrary constant here. So I'll just say plus c. Okay, so you could choose to, do some simplification. I don't have enough space to do that, so I'll stop here. This is our solution to the integral.